We're back live. Oh, maybe this did work. Hang on. See, here it was all ready to come back and not have anything work. But it's kind of doing stuff. Let me see. Very odd the way it is. What's this point here? 850. Parameters that we have here. Okay, tiny number of M's. Mini batch. Tiny batch. Interesting. 2 update epochs. So this thing runs at quite slow SPS. Interesting. Not super confidence inspiring though, either way. I think I want to look at the JE formula again. The sum of deltas. What are these deltas? Difference in value functions. But then these all cancel out. I was trying to see if there's a way to make sure that my formula could implement JE on its own. Delta T. Difference of values. But then the value function is maybe I'm doing this wrong. Is it trying to predict the reward or the discounted return? Where's the value loss? Where's the value loss? Ret. And then a ret comes from return, discounted return. Okay. I'm thinking of the formula that I would use for this. Maybe it's time to start doing some stuff in here. Whoops, where is it? Gamma equal I like this. There's our PPO paper. Why do they have this with a hat on it? because it's an estimate. It's annoying. If I start learning RL, can I follow you? Please create a structured playlist which people can follow. So these are just all my dev streams, right? These are not necessarily educational. You can definitely learn stuff because this is just watch RL research happen live. But if you're looking for educational resources, my RL quick start guide, and then start building M's for PufferLib. These are the two things, and that's outlined there as well. Like that guide kind of has everything you need to get started. This at the moment is me trying to come up with better formulations of a new algorithm I'm working on. Hey, how's it going? Okay, so this is what we have so far, I believe. Then we have PPO here. This is delta t here, lowercase delta t. So this is our new formula. tricky because their value function is defined differently. Because their value function is a difference in estimated returns. Was this function even right? It looks kind of weird. Gamma value of the next state. Is that right? Oh, no, because you look at it normally, this is the end term. So you normally look at it this way. So it's reward minus value here. I think these are actually the same because the way I have my value function defined, right? The way I have my value function defined, it's so obnoxious though. Maybe we look at the value function first. Because right now I'm just training value function to predict reward. So if I define, maybe I just define discounted return next. That makes sense. I think so. What do we think about this as a return? It's a discounted. It's a variance discounted sum. Okay, so now if we have this, can we do PPO with this? Or can we do JE with this? Let me see. What value is sigma representing? Sigma is the standard deviation that is output by the value function because we've made the value function variational. So the value function outputs a mean and standard deviation estimate. Basically, there's a bunch of math here, but all I'm trying to do is I'm trying to replace lambda and gamma with a learned estimate based on the confidence of the value function. That is what I'm trying to do. I have 500 on this one. Holy. I mean, the way that they define this thing. Can I not just do this? No, you can't because you don't have gamma. But maybe you do have gamma, right? Maybe you do have gamma. Didn't you define gamma? You did define gamma. So can't you just compute JE then? And you define gamma sub t, so you don't need this discounting. What if you just did this? Does this make any sense? Because really, gamma lambda to the L sigma v this is guaranteed to be 0 pretty much. Hang on, isn't this... Man, I hate mathematicians. Maybe not in, like, pure math, but in CS, holy fuck do they make things confusing. This is the worst possible notation for this. Okay. Because here's the thing. This value function is trained to predict this, isn't it? Isn't it trained to predict this? I think it is. B returns. So this here, it's advantages plus values, right? And then if you go to here, it's just this. So ignoring this k term at the end, it is. So all this is the difference between the discounted return and your prediction of the discounted return, right? And then for some reason we exponentially weight again. But the hope is that we delete this parameter because now we have a learned parameter. Oops. Hang on. We leave it? Gotcha. Yeah, I'm ready. Yeah. Alright. I have to go to dinner in a little bit, but I think that we actually hit on something here. So, for the folks on YouTube, let me explain what this is and why this is so exciting. The key advantage estimation here, right? This is PPO. This is like probably the most important algorithm in RL. The key advantage estimation, you can kind of ignore this term because this goes to 0 for large enough k, is this. What is this? This is your value function. What is the value function trained to predict? A discounted sum of rewards. This is a discounted sum of rewards. So all this advantage function is it is the discounted reward sum, which is called the return. So it is the return minus your prediction of the return. Okay, and then they do this mess to get this additional weighting term on the different terms of advantage. We don't care about this because we don't have the problem that we can learn a more flexible gamma than they can. So I think that all we have to do is take this function right here, we replace gamma t with our learned estimate for gamma t, which is going to take into account, this is the variance essentially. This is just 1 over the variance of our prediction minus a baseline. This is essentially just saying how much more confident. This is just saying how confident are we in our prediction, knowing the underlying, like how accurate you're likely to be by guessing. So this is our discount factor, and we can define likewise our return as a sum over these. And then I think we can just use this original advantage function and just predict the discounted return. And I think this actually solves our problem. What kind of attribution, linking? It depends what you're using it for. Hang on, let me check that. But yeah, that's why that is so big. Because I think that this will let us replace JE with this. I do have a DM on here. Request, accept. Well, it depends what you're using it for, right? Let me send you the image I sent to that guy. Where did we send this? Copy image. I have this banner you can use. It's a nice banner. Anyways, yeah, for folks on YouTube, I think what's going to happen is we're going to try this. I don't have time to implement this right now, but this is very quick to implement based on what we have now. And I think that this should allow us to essentially learn a flexible set of discounting parameters without having to specify them, which should allow us to improve over PPO. So right now, we're not even doing this discounting at all. We're kind of just like, we're like doing it element-wise or something. I'd actually have to think about what the thing we're doing now even does, because it's not that it's like failing. It's still kind of working. It's just not working as well as we would like. So I'm going to let this run. I'm going to get dinner. I may be back later tonight, maybe not, but sometime in the next few days we will work on this. Probably tomorrow is going to be all day on stream doing research on exploration methods in RL. That's another area that we are investing in. So yeah, you can drop by for that. But for folks watching, all my stuff's at puffer.ai. Started the GitHub to support the project. And otherwise, check out the Discord. You can get involved here. And follow me on X for more. Yes, do start the repo. It really, really helps us. when people start the repo. This is the fastest growing project in reinforcement learning. It's now one of the largest ones as well, based on stars. So yeah, this really helps. Anyways,